Let's take a look at a couple of problems that work with exponents. So sometimes we're working with the case of a missing value. We just gotta think about our exponent rules and how to work backwards. So in these cases here, we're going to be finding the missing x. So I have x to the negative 4 is 1 over 16. Well, the negative sign means that we're going to be working with the reciprocal of this. So that means x to the 4 is 16. And then what times itself 4 times is 16? Well, x to the 4 equals 2 to the 4. Thus, x equals 2. So that's it. We can revert or invert this because of the negative sign. That gets rid of it. And then we can just determine what to the power of 4 is the 16. So we can use that same process over here on part B. We have x to the negative 3 is 1 over 64. So that means that x to the positive 3 will be 64. And then something times itself 3 times is 64. Well, 4 times 4 is 16, and 16 times 4 is 64. So 4 to the power of 3 would be equivalent there. And then that means x equals 4. Now in this next case, we got a little bit of a different situation because we have 3 to the power of x. And that equals 1 over 81. So right away, we know that the x value is going to be negative because it's 1 over 81. So we got to figure out this here. This is going to be 3 to the power of negative what is equal to the 3x. So 3 to the power of negative what is 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. That's 3 to the power of 4. So 3 to the power of negative 4 would be 1 over 81. And thus our x is negative 4. In the next one, we got a fraction. Now, if we take a look, we have 2/3 to the power of x, so we got to figure out what exponent we would use to create 27 over 8. Notice 2 will not multiply and become 27. The powers of 2 are 2, 4, 8, 16, 32. Kind of skips over 27. But it does have an 8. And 3, as we said earlier in part C, will go into 27. This must be a negative x. So it's going to be 2 over 3 to the x equals something, or 2 over 3 to the power of a negative value. And what's that negative value that works? Well, 2 times 2 is 4, times 2 is 8. 2 to the power of 3, and 3 to the power of 3. So there's our x. X equals negative 3. And the last one here, x to the negative 2 is 4 over 9. So we're just working this fraction in reverse now. So that negative means this is going to flip over. So x to the positive 2 would be 9 over 4 in that case. And then the x value, what exponent would we use? Or what would we make to the power of 2 to get 9 and 4? Well, 3 squared is 9 and 2 squared is 4. So x squared equals 2 over 3 squared, and thus x equals 2 over 3. There's our result. Now, that's just a little bit of thinking in reverse with these and trying to find some missing values, get you thinking a little bit. Now we're going to take a look at half-life. So we're talking about some elements that are out there. You've heard of radioactive elements. These are unstable elements that try and become stable by giving off radioactive particles in a process known as decay. And I'm oversimplifying this, but basically what we're doing is decaying and losing mass as they try and become stable. And so this decay is measured in a half-life. So half-life means how long it takes to get to half the original amount. So in this example here, we got iridium-192, which is used in nuclear medicine to treat some types of tumors. It has a half-life of 74 days. So every 74 days, you will have half as much as you had 74 days earlier. So if you had 1 gram today, in 74 days, you would have half a gram. In another 74 days, you would have half of a half, or a quarter of a gram. Now, using that thinking, let's complete that first problem. Make a table to show the amount as a fraction and power left after 74, 148, 222, 296, and 370 days. So after 74 days, we have half as much. 1/2 as a fraction could be written as 2 to the negative 1. After another 74 days, we'll be at 148. So we will have 1/4 of the amount, or 2 to the negative 2 as a power. Another 74 days, we'll have 1/8, or 2 to the negative 3. Another 74 days, we'll have half of that, which is 1/16, which is 2 to the negative 4. And after another 74 days, we'll have 1/32, which is 2 to the negative 5. So there's our decay in each case. So we can use that information to determine that if we started with 3 grams of iridium-192, how much would we have left after the 370 days? So that is 1, 2, 3, 4, 5 half-lives. So after 5 half-lives, we would have 3 times 1 over 32, which equals 3 over 32 grams. Or we could use the exponents, 3 times 2 to the negative 5, which equals, again, 3 over 32 grams. Notice here, that's the number of half-lives that it went through, 1, 2, 3, 4, 5. That is the same as 370 divided by 74. How many times have we gone through 74 days? Now, in converse to half-life is doubling time, and often we look at bacterial cultures in terms of doubling time. So if we have a bacterial culture that is made up of 2,000 bacteria at 10 a.m., and they double every hour, we want to write an equation to model the growth of the bacteria. So the growth, the amount of bacteria we have, would be equal to 2,000 times 2 after 1 hour. And after 2 hours, we'd multiply by 2, and then we'd multiply by 2 again, the first hour, the second hour. Then we multiply by 2 after the third hour, and 2 after the fourth hour. So whatever number of hours goes up here as an exponent. A is the amount, and T is hours since 10 a.m. It's important to note hours since 10 a.m. How many bacteria are there at 1 p.m.? Well, 10 a.m., we go 11, 12, 1. That's 3 hours later. So we can use our formula. A equals 2,000 times 2 to the 3. 2 to the 3 is 2 times 2 times 2, or 8. And 2,000 times 8 is going to be 16 16,000. So there are 16,000 bacteria at 1 p.m. Notice this grows very quickly. Now, we have, when were there 250 bacteria? So now, if we take our formula, we want to know the time when there were 250 bacteria. So we use our formula. We're trying to find T now. So let's clean this up a little bit by getting rid of this part here. We're going to do 250 divided by 2,000 equals 2 to the T. 250 over 2,000, that's going to be 1 over 8. This is going to be a negative exponent. So we're going to have a negative exponent here. 2 to the power of 3 is 8. So 2 to the power of negative 3 is 1 over 8. So this is 2 to the power of negative 3. And that's our 2t. So negative 3 equals t. So 3 hours. Negative 3 hours would be 3 hours before 10 a.m., which would be 10 a.m., 9 a.m., 8 a.m., that's 7 a.m. So there were 250 bacteria at 7 a.m., 3 hours before, that's the negative, 10 a.m.